In section 3.1, we're talking about sampling distributions, which are just what's the distribution of a sample statistic look like if you computed it for various different samples of the same size taken from the same population. So we're looking at like what sort of shape do we see, where are they centered, how spread out are they. So we're going to do some simulation with the data set built into StatKey, which is the baseball players 2E 2015 salary. So I'm going to go to StatKey and then I'm going to go through parts A through F of this example. If we go to StatKey and we do sampling distribution for the mean, this is going to allow us to pick our data set and draw samples of whatever size we want. So we're looking at this baseball salary data. Okay, what we wanted to do first was just give a couple of bits of information about the overall data set. You can see in the upper corner under population that N is 868, so we have a total population size of 868, and the mean salary is 4.215. What we're interested in looking at then is if I take a sample of players from this larger data set, this larger population, what do the sample means or the X bars look like? So I'm going to generate one sample first. We're looking first at taking samples of size 10, which is already set here at the top, and I could change that value to whatever I want, so we're going to keep that set at 10 here. And then I'm just going to click generate one sample up in the corner. So we can see that there's a little dot put on our plot there. So our first sample of 10 players gave us a mean of 5.383. And that deviates a little bit from our actual sample or our actual population mean of 4.215. The question is, what's going to happen if I keep taking samples of size 10? So let's generate one more sample. Our next sample gave us, if we look in the lower corner under sample, we see the mean is 3.634. And then if those two dots are now on our plot from last time and this time, and they averaged a 4.508. If I generate another sample, another one, what this is doing each time I click generate one sample is it's taking a different sample randomly of size 10 from the 868 players and looking at the mean. So to get an idea really of what these are going to look like if I take a lot of samples, what we want to do is take 1,000 of them. And notice if I keep doing one at a time, where are they sort of centering around? Well, we're getting them centering 3.6, 3.7. If I keep doing this, what we are expecting to happen is that they should start to get closer and closer to the actual population value of 4.2. So let's reset this, and we can just click the button to generate 1,000 samples. So what this did was took 1,000 different samples of 10 players from our 868 and found X bar. So we have 1,000 X bars in this dot plot. We see that they center, the 1,000 X bars have a mean or center of 4.253, which is very close to the actual population mean for the players of 4.215. We also can look at the range of the values. So what range the sample means lie from. We can see they're around like 1, maybe around a half, up to, I don't know, somewhere around 10. The reason we're looking at that right now is because we're going to change the sample size and see how that affects what we're getting. So what we want to do now is reset the plot and consider 100 baseball players instead of 10 and see what happens. So we'll begin by doing them one by one and kind of get a feel for that again, and then we'll just have it generate a whole bunch at one time. So I'm changing the sample size up top to 100, and if I generate a sample, there's one mean. Let's generate a few here. So they do bounce around. Every time we take a sample, they're a little bit different, and we can see that these are starting to get a little closer to that 4.2 already that we have as our population value. And they're not deviating that much from each other. So let's reset this and generate 1,000. So if we look at the average of the 1,000 averages, the 1,000 X bars in this picture, we can see that's at 4.213, and that is very close to our population mean of 4.215. And the last one we had said that the range we were getting for the X bars was around like 0.5 to 10 or so. Notice here that the range is not as much. We still have some values that are a little lower, but for most of these values, they're only going from around 3 to 5.5. So this tells us that when we take larger samples, that the X bars that we get back do not vary as much, or we have a smaller variability in the values that we're getting.